Hi, this is Chong Kim, and welcome to How to Learn a Language Quickly and Make It Stick. I've been a programmer for over 20 years, and I learned a lot of languages. Every time I learned a language, I also wanted to improve the way I learned it. Um, so this is a summary of that experience. Uh, so Malcolm Gladwell wrote a chapter in his book, The Tipping Point, on stickiness. It was about Sesame Street and Blue's Clues. Sesame Street wanted to use the same techniques that advertisers used on kids. They wanted to make short segments that grab their attention and be entertaining, but they would also slip in the education. So of course, they were successful, but along the way, they learned a lot. They learned that kids do want to interact with the show. For instance, there was a segment where Kermit the Frog placed his finger in the air and traced the letter O on the screen. They found that these preschoolers would go up to the TV and trace it along with him. In another segment, they had James Earl Jones recite the alphabet, and in between each letter, he had a pause. Originally, they intended to put some elements in between, but after seeing the segment, they decided to air it the way it is. So uh, here it is.
A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z.
Well, I don't know about you, but I found it this riveting. um, so when kids saw this, the first few times, the kids would say the letter after he said it. Then, after watching it a few more times, they would say it along with him, and seeing it some more times after that, they would say it before him. And the pauses, they allowed the child to interact, and the repetition of seeing this over and over again made it stick. And so some of the people working for the Children's Television Workshop wanted to take these ideas and run with it. So they went to Nickelodeon and created Blue's Clues. Blue's Clues was pretty radical. They took an episode and ran it 5 days straight, Monday through Friday, and they had uh, pauses longer than what you would find comfortable, and um, and they had a purpose. Uh, each episode had a puzzle that would be solved by the end of the show. So here's a typical scene.
I wonder how many potatoes we should feed the pigs. Great idea, Blue. This chart will tell us. Which pig gets the most potatoes? Well, which pig has the longest line?
That one, the brown pig.
The brown pig. Because the line next to the brown pig is the longest. So the brown pig gets the most potatoes.
Well, when I first saw this, I found it a little bit unnerving um, because of the pause. Um, but a novice doesn't see it the same way that an expert does. So when they're seeing this for the first time, they're missing all the visual cues, so the answer isn't obvious, and so they need the repeated viewings to catch these cues, and 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 the pauses allow them to participate. So basically, transition from being a passive viewer to an active participant. So the idea of passive and active um, remind me of a study in 1963 by Hein and Held. The Kitten Carousel study had kittens raised in the dark and only allowed 1 hour of light a day. In that 1 hour, they were placed in a device so that one kitten, the one on the left, um, the the passive one, couldn't interact with his environment. The other kitten, the active one, um, was allowed to interact. And as you can see from this device, that when the active kitten moves, so would the passive one. And if the active kitten turns, so would the passive one. So the passive kitten had the same visual experience, but without the interaction. So by the end of the study, the active kitten was normal, but the passive kitten was functionally blind. It would bump into walls and act as if it was blind. So this study left a deep impression on me. This meant that in order to learn, you need to interact with your environment. So let's get down to how to learn a language quickly. Here's the recipe. First, gather knowledge and tools. And some of these are pretty obvious, like read a book. You need to find online resources. You don't have to keep all of this in your head. So when you read a book, you're not trying to memorize it and know everything that's in the book, because in practice, you can always refer back to it, especially since you can Google the stuff and have it at your fingertips. So there's no reason why you need to really study it. It'll just come naturally. Um, so you can read a book and go to Stack Overflow, download the documentations. Um, Koans, I'll talk about that later. Um, and there's also FAQs, FAQs, frequently asked questions, and this is a really good source of uh, typical questions that you would have. So, for example, like if you had an error, it would then they would explain like what your problem is, and this is the kind of thing that you wouldn't find in books. The problem with books is that books don't show you errors. So most of the time when you're programming, you'll get compile errors, syntax errors, um, but the book doesn't show it. And it also doesn't tell you how to deal with errors. So when you're looking at the book, you see perfect code, or if the code is broken, it's only because of a logic problem. And so book has its limits. So when I was in college, I took a course in logic. The professor asked, "What is a chair?" If you take a look at the definition, it says, "A separate seat for one person, typically with a back and four legs." So if you take a look at the horse, it has a back and four legs, and you could sit on it. So if you don't know what a chair is, then you would think, okay, maybe this is a chair. But you know it's not. But you're not sure. So you take a look at the second picture. Well, that has a seat for one person. It doesn't have a back and four legs, but it says typically, so still, well, obviously this is not a chair. Then you take a look at the last picture, the one on the right. Well, the office chair, it has a back and well, it doesn't have four legs. So then you think, okay, this may not be a chair, but you know it's a chair. And that's the problem with books. When you read them, you think you understand it, but when you see it in practice, you're never quite sure. Defining something or stating a fact, well, that is one way to do it. But if you want to tell somebody what is a chair, you can point to it. You can say, this is a chair. Humans have a very powerful pattern recognition machine. So if you show them one chair and then show them another one, they can tell whether or not it's a chair. And the more chairs that you show them, the more confident they can tell you if something's a chair or not. And that's one of the reasons why I made these YouTube videos, is because I want to show people that this is programming. And that's a problem with education. In education, they teach you about programming, but they don't show you. So the professor doesn't bring up his laptop and start a project from scratch. And that's like a martial arts teacher who doesn't show you how to kick, and he would just explain it to you. So and he'll leave it up to you to figure it out. And that's what happens when a lot of times when you take classes, they explain things to you, and they tell you how and when you should use it. But when there's a project, you don't actually see it done. It's up to you to figure it out. Okay, koans. Koans itself means, well, it's something like, what is the sound of one hand clapping? But in programming, koans they're short tests that are failing, and you need to make it pass. Each test covers a feature of a language, and the set of koans, if you do them all, you pretty much get a very good sense of the language, because there's a test for each of the features. So let me show you what koans are. Okay, so this is Ruby koans. This is what started it all. Ruby koans was created by Jim Wyrick and Joe O'Brien. And they have two versions, one you can download and you can try it online. So let's try it online. Okay. Koans, all right. So we have our first test. Okay, so about asserts. Okay, we shall contemplate truth by testing reality via asserts. The answer which you seek. False is not true. So it says this should be true, so let's make this true. I press carriage return, and now it's green. Green means that it's passing. So then we go to the next one. So this basically tells you that assert is expecting whatever is passed in to be true. So this one, the point of this, it says this should be true. Actually, this says the message here. So enlightenment may be more easily achieved with appropriate messages. Okay, so this is just showing you that you can pass a message into here. So let's make this true. Okay, great, it's passing. Okay, next. All right, false is not true, so this is false. So let's make it true. So 2, and press character turn. Okay, so now that's passing. The next one, now instead of using assert, it's using assert equal. So some ways of asserting equality are better than others. Okay, so 2. All right. Okay, that looks like that passed. Okay, so now you have the last one here. It says, sometimes we will ask you to fill in the values. So this time it's assert equals, and it's put in directly in here instead of having these separate variables. So I'll make that 2. So 2 and 1 plus 1, they should be equal. Okay, so it says here about asserts has heightened your awareness. So we've just completed a set of koans. So 1 out of 30. So next is meditate on nil. Okay, so once you pass about asserts, now we go to the next one. So it starts off very easy, and it gradually gets more difficult. And by the time you get to the end, you pretty much have a good foundation for your knowledge. Okay, so let's just try this one for nil. So nil is an object. Okay, so let's just say true. It says unlike null in other languages. So we say true, and that passed. So you could see yourself going through these one by one, and if you had chosen the other path of downloading it on your laptop, so okay, so if you download it on your laptop and you unzip the file, you'll end up with this koans directory. And if you read the README, they have instructions on how to use it. You need to install gem install watcher. I already have this, so well, if I press return, it'll just reinstall it. Okay, so you installed watcher, and let's just run it. We run it on the koans watcher file. And make this font a little bit bigger. Okay, so we run it, and what it's doing is it's watching for any changes of the file. So if I go in here and edit the about asserts, okay, make this font a little bit smaller. Okay, move this. Okay, so about asserts. Okay, I already started this, so this originally was false, so let me just save this. And we have this error message, and tells you the line number. It's on 16, and the master says, you have not yet reached enlightenment. You're progressing. Excellent. 1 complete. So that's because of this statement right here. But it says that you have a problem. This should be true. So they talk about line 16. So let's go to line 16. And true. Okay. So now we're up to line 25. And 25, let's just take these underscores and make this 2. So now the expected value and the actual value should match. Okay, so now we're on to the next one on line 33. So you can see this is pretty much the same as the website, and it gives you a little progress over here. 282 koans, and which is a pretty good size. So once you go through this, you get a pretty good sense. don't worry if you get stuck on something, because you can always refer back to your reference and come back to the koans. At the very least, what the koan does is it alerts you to the fact that some of these features exist. So if you go out and look it up, that's fine. Now you know. All right, so this is Ruby koans, and other languages also have koans because they took the idea of the koans and just ported it to their own language. So let's go to if you Google Python koans, you'll get to this GitHub page, and you can download this. And when you download it, it's basically the same setup. So if you go to Python, okay, let's use Python 2, and so you have a runner. Actually, there's run.sh. So all you need to do is just read the instructions. So I think the instructions were in the directory above. So let's see. Yeah, there's the README right there. So if you read through that, it tells you how to run it. Okay, so you just run sh, and then you need to go and modify that file. Okay, so let's see. So you have one for Python. Here's the one for closure. These are the instructions for running it, and okay, all right. So, and this is for Haskell. So you can see it's available in a lot of languages. So you should try it out. Just type in your language and koans. Okay, another powerful tool that you have is the REPL. The REPL stands for Read, Evaluate, Print Loop. So basically, this is your prompt. If you have an interpreted language, they usually have a REPL. And let me show you. All right, so let me show you the Ruby REPL. So Ruby has IRB, but there's actually, I prefer pry. Okay, the reason why is because it does the same thing as IRB, but it has some extras that really makes this really nice to use. So let's say, for example, well, you can say ls. Usually ls in Unix means, list the directory, but with ls you can give it an object or whatever, and in this case I gave it an array, and this tells me all the methods that I can use on the array. So there's clear to probably empty the array. You can reverse an array, and you notice that there's array and there's enumerable. Enumerable is inherited, so it's an array, but it also inherited these methods. So if you ever stuck not knowing what to do with an array, you can just do ls. And sometimes I would just do this and take a look to see how much of these I know. And if there's one of these that I'm not sure about, I usually just take a look at the documentation. So I can do it right here. Say ri, and let's say rotate. So this one right here. So how does that work? So if I say ri rotate, then I get the docs for that. And you can see here that A, B, C, D, if you do rotate on it, now it becomes B, C, D, A. So it moved the A from the beginning to the end. And there are other ways that you can, oh, this one lets you know that the original array hasn't been modified. So you can see it's still the same. And then you can rotate 2, and you can see that it shifted over by, so we called it twice, basically. Okay, so that's for Ruby, and you have the same thing for Python. So if let's get out of here, and if I were doing some Python code, I could use Python, or I could use IPython. And let's say that I had an array and I want to find out something about it. And okay, this doesn't have as many, but you can see that you have append, count, and also they have functions. So if you have functions like len is a function. So maybe better if I say print. You can see that len has the documentation saying that it returns an integer, returns the number of items of a sequence or mapping. So this is if you learn to use your REPL that comes with the language, then you don't really have to keep a reference book at hand because it's available to you. Now I want to show you a closure. So Line REPL, they have cdoc. It's not mentioned here, but cdoc is pretty cool. You can say cdoc and then you give it a function. And it tells you how to use it. So they give you examples. So instead of giving you a bunch of documentation, it says if you call it like this on this data, then the one is inserted, and you can just see just by looking at this what it does. So that's the REPL. So these are really good tools to just gather your knowledge. All right, so now that you're gathering this knowledge, I need to tell you about recall versus recognition. When you're learning all these things, what you want to do is you want to have recall. So the difference between recall and recognition is that recognition is when you're taking a multiple choice test and you can recognize the correct answer. That's recognition. Recall is more like fill in the blank, where they don't give you a clue to what it is, but you have to draw it from your memory. So recall is the way that you want to remember it, not through recognition. Basically, if you take this knowledge that you have and just pretend that you don't know it, like you just forgot, and then you try to recall it, then that would make what you've learned stick. And another way that you can make it stick is by associating it with meaning. So once you learn this fact, you try to associate this new knowledge that you gain with other knowledge that you have and put into the right context. When would I use this? This would make it so much easier for you to recall it because now you have multiple ways of fetching it. So the best way that you can use recall is just by taking a guess. So you don't know what it is, but you just take a guess, and it doesn't matter if you're wrong because at least you try to recall that information, and then you go look it up and see if it's correct. And if it's not, then the next time you try to recall it, then you have a much higher chance of having it correct. So the more times that you try to recall that information, making guesses, eventually you'll get it right and it'll stick. When I read a book and I go through the tutorial, I don't actually do the tutorial, I just read it. And when I get to a certain point, I would put the book down and try to see if I can do it myself. The first time you do it, you're going to draw a blank because you're just not used to the environment. But you try to recall it, but you're recalling from an empty source. So then you go to the book, you search for what the right answer is. Like, how do you start? So what was that function called that I'm supposed to call? And then you see it. Ah, so that's what I was supposed to call. And then you put the book away, bring up your editor, and you try it again. You can try it immediately or you can wait a while. Because what you're trying to do is you want to exercise that part of your brain that's using the recall and not your temporary memory. So usually if I read a lot, I would just take a little break and then so this way your mind is clear and fresh, and you would just start doing whatever the tutorial was trying to do. Let's say, for example, it was trying to create some widget, and using some API calls. So then you would sit down and now you remember, so that was the function that I was supposed to call. You recalled it and you try to see how far you can go, and you'll get stuck. So in the beginning, it's going to feel very uncomfortable because you're not going to make a lot of progress. But then you keep doing this and you go back to the book and you find out the answer, and then you'll get a little bit further along. And eventually you'll get to the point. You'll definitely get to the point because all the answers are in the book and the instructions are right there. So after you finish, you get this real sense that you've accomplished something. That if you were asked to do it again, that you could. And that's the power of recall. Because if you just have read the book and just followed along passively, then after you're finished writing the code and the code works, you don't really get a sense that it's going to stick. And it's probably not. And the knowledge just feels tenuous, like as if it can just evaporate at any point. So try to just remember about recall, that you want to use that technique to strengthen your long-term memory. So the tip is for the memory to not really to memorize it. So just forget. When I find new pieces of information, usually if I wanted to make it stick, what I do is I just do something else and then come back to it probably like an hour later and see if I can recall it. And if I do, then chances are that I've pretty much understood it. And also, don't focus on the details, because using the other techniques, when you're actually using it in practice, that'll just reinforce your knowledge, and just knowledge sticking would just happen naturally. Another thing that I'd like to do is record myself practicing, and when I do, I try to capture myself. I try to see how far I can go in an hour. And in the beginning, I wouldn't be able to recall anything. So I would probably just go on Google and search. But eventually, after the hour, you see how far you've gone. And then you try it again. But within that first time, you've learned something. So hopefully, the second time you do it, you would accomplish a lot more. Another way of making these things stick is by knowing one language and learn it well. Because language has a tendency to copy from other languages. So if there's a feature in one language, then eventually, either through external packages or something, that they would add it to their language. Like for example, Ruby has enumerables, like the one that you saw in the REPL. I was using JavaScript and I saw this package called underscore, and I thought this JavaScript library is probably going to take me a couple of days for me to figure out, because you expect libraries to have a lot of functions. But when I opened it up, I saw that enumerables the underscore basically implemented what enumerables were. And I knew enumerables from Ruby, and even though I was working in JavaScript, I could use underscore immediately rather than thinking that I would spend 2 days trying to figure out how this worked. I already knew it. So you'll see that these sorts of thing happens all the time. If you know one language, just try to learn it as well as you can, and you'll see that a lot of those features would show up in other languages. Okay, so let's go back to the recipe. So we managed to gather our knowledge, and I talked about some of these things. You need a way to find feedback. So REPL is how you can get feedback, so you can try stuff out. A debugger is also a good place. And if you can have automated testing, just like with the Watcher, where you modify one file and it would run the test automatically, that gives you instant feedback. So when I was doing it, I just saved the file and I could see whether or not it worked. So that's so you should do a search for automatic testing for your language. So in Ruby, the language that I usually work in, um, I use guard. But guard can be used for other languages as well because there is a gem called guard shell, so that when a file gets changed, it runs a shell command. And that command could be something like compile this program and then run it. So you could use it with C. And if there is, if you have Python code, then you can use guard to run the Python script. So speaking about feedbacks, this reminds me of the classroom experiment. Now, I heard of this experiment, but I'm not really sure if this was actually done, but it has a pretty good lesson. So the classroom experiment, you have a teacher that selects two students. They both leave the classroom. The teacher takes their jacket and hides it somewhere in the room. One of the kids comes in, and the class is instructed to say yes every time he's going in the right direction. So he starts off in the middle of the room, starts poking around, and he hears a yes. So he goes closer and he hears another yes. So he keeps hearing these yeses, and he's able to find his jacket pretty quickly. Okay. They bring in the second student, and this time the class is instructed to say no every time he's going in the wrong direction. So he starts in the middle of the room, and he hears he starts poking around same way as the first guy, and he hears a no, and then he hears a no, and he hears more no's, and the teacher stops the class, and she says, "Did you see what just happened?" He froze. So that's what happens when you get negative feedback, is that, or too much negative feedback, then they freeze. And if you think about it, that's exactly what happens when you're programming. When you're programming and you're confronted with errors, then you freeze. You don't know what to do, and you get sort of this mind block. But in reality, error messages are positive feedbacks, because if you're an expert and you are able to read the error message, then you know exactly what's wrong. It says the line number, it tells you the reason, and you go and you fix it, or you have at least an idea of how to fix it. Now remember that novice, they don't have the same visual cues as the expert, so when they see an error message, they don't see it the same way. They just think of it as a negative feedback. But if you learn to read the error messages and associate that with how to solve it, then you see that as a very powerful positive reinforcement of positive feedback. So what you should do is spend the time when we're faced with an error message to explore it, and once you figure it out, to remember how you did that. So for example, one of the common cases is if you forget a curly brace or an end, and so you have these blocks, but you don't know where the end is, where the missing end is. So the way that I figure this out is by using auto indent. So a lot of editors automatically indent your code. So if you let it auto indent, then if you forget an end, then it'll indent it it'll be off by one indentation. So if you just indent the whole file, you can see automatically where it is. You just trace back and see where the indentation is off. Okay, so we have gather knowledge, find feedback, practice. Okay, so now we have practice repetitively. To do that, there are katas. A kata is, in martial arts, kata is choreographed movements. So they practice, initially when they start off, their kata is really simple. And as they progress, it gets more and more difficult. And each time you learn a new kata, there's new elements. So in the beginning, for a white belt, they would just block and punch. They would do a low block, punch, low block, punch. And when you get to yellow belt, maybe you do a different kind of block, like a high block, punch. When you get up to green belt, maybe you'll kick. By the time you're black belt, maybe you'll jump. So in programming, you start off with some easy exercises and you eventually progress to harder and harder ones. And when you do these exercises, you should have some type of goal. Every time you do it, maybe you want to get better with your editor. So each time you find some way to make your programming faster by finding shortcuts or finding a new package that you can use. For example, I use snippets, and snippet has blocks of codes that you can use. So if you type if and tab, then it would automatically fill it in. Another purpose is to achieve fluency, to try to see if you can just write the code as if it's coming straight from your head without any pause. Because after all, when you're talking, it goes from your head and you say it. If I were to talk very slowly, then you would have a hard time understanding what I'm saying because it's taken a while. And that's exactly the same thing with programming. So if you're programming and you find yourself taking a long time to do something, then the concepts in your head are not coming through. So you want to make sure that everything is smooth like that. Another goal is probably to use idioms. So when you first write your code, you probably write it in the most logical way that you can for what you know. But if you just do a Google search on the language of your choice, so let's say Clojure, and you say Clojure idioms, then you'll see search results where you'll find people listing out some of the idioms or Stack Overflow, and they're a good source. The web is a really good source for idioms, and once you do, it can dramatically improve your code. The thing about practice is that there's this idea of the 10,000 hours. The 10,000 hours came about from a study done in England where they were studying world-class musicians, and they were also studying musicians that also went to the same school that ended up being teachers. So there's a big difference between being a teacher and playing in a world-class orchestra. So they looked at all the different factors on these people, like height, race, and, socioeconomic factors. But there's only one attribute that stood out that pretty much determined who was going to be a world-class musician versus somebody who wasn't, and that was 10,000 hours. So if you achieve 10,000 hours of practice, but a very specific kind of practice called deliberate practice, if you manage to get 10,000 hours, then you can achieve this level of excellence. And if you think about it, if you do the calculation, 10,000 hours, if it was a full-time job, 8 hours a week, 8 hours a day, 5 days a week, that ends up being about 4 years. But studies showed that after about 4 hours, the effectiveness of the practice goes down dramatically. So let's just say that it's 4 hours a day, and 4 hours a day is quite a lot. 4 hours a day comes out to take you about 8 years to achieve this level of excellence. Another thing they noticed was that it really didn't matter when they started. So there were some musicians that started at an early age, like 6, and there were some that didn't start until much later, like 10 or 12. But the difference can be made up because the ones that started later just practiced more, just spent more hours per day, and eventually they caught up. So as long as you have the 10,000 hours, and if you start late, you can catch up. So what is deliberate practice? So first, you have to realize that deliberate practice is working on your weaknesses. It has a very so when you have deliberate practice, you have a very specific goal in mind. You're not just repeating motions. You have a goal, and what you want to do is you want to break things down. So, for example, like Jerry Rice, he's a great football player. He doesn't spend that much time in practice actually playing football, then that's only like 1%. Most of the time is spent doing other things. He may be running to work up his endurance. He may be doing weight training for strength. So he works on very specific aspects of what he's trying to do. And so deliberate practice, you're working on just those pieces. So when you're doing a kata, you want to do it repetitively, but in such that you're just focused on one thing, and you want to achieve that. And once you get that, then you go on to the next one, and eventually you become better and better. Okay, so let's do a kata. So I'm gonna do a fizz buzz kata in Ruby. All right, so let me make a directory. All right, and when I'm doing a kata, kata is a performance. I strongly suggest that you record yourself when you do this, because then you feel like you're on the spot. Even though you may not be playing this to anybody, or even if you just delete it, you can review it and see it from the point of view as an observer, because when you're writing the code, you don't catch all the visual cues of things that are happening because you're so focused on doing one thing. But you may realize that you forgot to do something, or you think of a better way of doing it. So record yourself and treat it as a performance, like as if you want this to be the best. Okay, so here I am. I'm in the FizzBuzz directory, and the first thing I'm going to do is I'm going to create a spec file. I am going to open up Vim on spec FizzBuzz spec. Okay, make the font a little bit bigger. And on this, I'll just leave it like this. Okay. So I'm going to start over here. Okay, FizzBuzz. Okay, so I'm describing FizzBuzz. It expects FizzBuzz of 1 to be 1. The way FizzBuzz works is that if you have a number that's a multiple of 3, it's going to say fizz. If it's a multiple of 5, it's going to say buzz. And if it's a multiple of 3 and 5, it's going to say FizzBuzz. But any other number, it's just going to repeat that number. So if it's a 1, it's going to expect a 1. If it's a 2, then it expects a 2. If it's a 3, then it's going to say fizz. Okay. So I see that the first error message I get is undefined method FizzBuzz. So I'll create a function called FizzBuzz. Okay, and I'll just leave it alone. Okay, and it says wrong number of arguments. So I'll just make it pass in an argument. Okay. Expected 1 got nil. Okay. So the easiest way to make this pass is to put 1 here. Okay. And that passed because now it's complaining about line 7. So this one says expected 2 but got 1. So since this is dynamic, we might as well say n. So it's just going to return me whatever I passed in. Okay, so now it expected fizz but got 3. So let's put a little guard clause here saying return fizz if n is equal to 3. Okay, now we have our first passing test. So let's go to the next one. So FizzBuzz of 5 is going to say buzz. Forgot to put an end quote. Okay. So speaking of visual cues, notice that I forgot to put a quote. So because I forgot the quote, the syntax highlighting thinks that this whole thing is a string. So once I noticed that this was green instead of blue, I realized I forgot the quote, so then I put the quote, now it's blue. Okay, so okay, save, and got 5. So now I do the same thing here, except that I do it for 5, and this time it should say buzz. Okay, so that passes, but now we have to handle the multiples. So this would be 6, and this should be 10. Okay, so expected fizz, but got 6. And that was because this is only if n equals 3. So we have to see if this is a multiple of 3. And the way that we can do that is by looking at the remainder. So this percent means mod, which gives me the remainder. If I divide by 3 and get the remainder, what is the remainder after dividing by 3? Well, let's just check if it's 0. So if it's a multiple of 3, then I want it to say fizz. So that passed because it went directly to the next error, which is it expected buzz but got 10. So we do the same thing. Expected 0. Okay, so now we have 6 of these things passing. And let's try it for fizz buzz of 15, which is a multiple of 3 and 5. Then I expect it to be fizz buzz. All right. So what we can do is we can say return fizz buzz if n is a multiple of 15. Okay. So this got buzz. This didn't work because this caught it first because it is a multiple of 5, and so it caught it on the buzz. So this means that we have to take this and put it at the top. Okay, so now it's passing. So we have pretty much everything we need, so then we can go put this in a loop. So let's say of 100, and I'll just say print I, and that goes to fizz buzz of I. Okay, and you can see that this works. So if it's a multiple of 3, this is a multiple of 3, it says fizz. If it's multiple of 5, it says buzz. And here's fizz buzz because this is a multiple of 15. So that completes that kata. So every time I do this, I would try to see a different way I can do it, or I'll try to use different keystrokes. You can see here that I already made a keystroke for DE, so that creates a snippet. So when I press tab, that automatically puts it into a describe block, and that saves me the effort of coding. And also when I say it automatically fills all this stuff in, and that's from setting it up. But you have to be proactive about looking for these shortcuts. Another thing that I have that really helps me is Syntaxtic. It's a plugin for Vim. So if I made a syntax error, let's say for example I forgot an end, then it has a little mark over here mentioning that there's a missing end. Actually, probably a better way is if I let's say that I put like a colon over here. Okay, so that's obviously wrong. And I save, and you can see that it marks this line as incorrect, and it says that this is wrong too because it couldn't understand this line. So the whole block is not correct. And it's also highlighted here too, but it's right before it. So if I just change this and save, then those things go away. Another way that you could do katas is by going to this website, codewars.com. So once you log in, you can choose a certain type of kata. So I'll choose strings. And let's take a look at some strings as numbers. Okay. So here's a description of what it's doing. So you're given a string 1 and another string 2, and you're supposed to sum them up and return it back as a string. So let's try this out. Okay. So so this is in instruction, but now let's just try it out. So let's just do something really naive, like a plus b, and I do command return. Okay, the function must return a string value. So the reason is because I forgot to say return, and see. So now it got back a string. That test passed, but it says 1, 2, 3, 4, 5, 6. We should have gotten 579, but instead we just had those two strings concatenated. So what we need to do is parse the integer and parse integer again. Okay, so it must return a string value. So we have to take this whole thing and return it as, well, convert it into a string. Okay, so we have a lot more tests passing. But this one says that the first argument, if the first argument is null, then we should return a 5. So let's do that. So if A happens to be the empty string, then I want it to return B. All right, and then we get the next error, which is we have this really big number and added to this other big number, but we got the wrong result. And the reason is because it's probably because this number is too big to fit into an integer. So we would have to do some string manipulations by slicing this and add up the components. But I think this is a good point to stop, because you get the idea. So you keep on going, and once you have a solution, then you can take a look at other people's solutions. Let's go here, and I'll go to edit languages, so you can see what languages are available. Right now we have Ruby, JavaScript, and CoffeeScript, and these languages are coming soon. So if any of these languages are something that you're interested in, then you should check out this site maybe sometime later, and you may be able to start doing katas. Another website that you can try is exorcism.io. It works a little bit differently, because you don't do the exercises on the web. Instead, you download the client. So here's the instruction. So you download the command line client, and you have exorcism. Then you can use exorcism to fetch exercises, and you do them on your own laptop. Basically, you're given tests, and you have to make them pass. And once you have it passing, then you submit it back to exorcism, and and it will be put on the site for people to look at and comment. And also, you can go and see other people's solutions and leave comments there as well. So let me log in and show you what happens, what it looks like when you're logged in. Okay, so here I can take a look at other people's solutions. Because I've done this this exercise in Haskell, it's telling me about somebody else who did the same thing. So I look at their solution, and there's and you can see that somebody else have left a comment for them. For extra usability, you could do something like whatever. So you can leave some feedback, and here I could leave a feedback here as well. Now let's go back to my account. So my account, I've completed these exercises, and I can go and see um, see this, and this one nobody has left a comment, but Haskell isn't a very widely used language, so there's probably not a lot of people doing it. But you would see comments about my code and see if there's any way that I could improve. Okay, so that was the kata. Now, when I was in college, I had a friend who was doing an independent study writing a Pac-Man game for artificial intelligence, and uh, he made he found something interesting, which was that if the ghosts had the optimal solution, that it was pretty easy to defeat. But if the ghosts had one of the random algorithms, then it was tougher. And this was a bit of a paradox. Why would an optimal solution be uh, be so much easier? And the reason is because if they were using the same algorithm, they tended to clump together and so act as if there was just one ghost. And and I thought this was kind of interesting, and I thought about and I thought about this every once in a while, and I realized that when you're learning, that if you don't have one method of doing something, that even if it's the most optimal way to learn, that it may not be enough. That the idea or concept may be elusive, and what you need to do is you need to come up with a strategy to approach it in different ways. It doesn't matter if it's good or bad; just try it out, and eventually you may be able to corner the concept and really grab a hold of it. All right. So after you've practiced after you practice repetitively, now you have a sense of knowing the language. So now you can actually try to do something real. By real, what I mean is you can start looking at different packages and figure out ways to write something that you always wanted to write, like for example a game, and you have to make it challenging because you want to you want to stretch yourself to do something that you're not able to do before. So what I just explained was basically Bloom's taxonomy. Bloom's taxonomy was created in the 1950s to study how children can achieve mastery. And they came up with this hierarchy. So at the very bottom, you have remembering. So basically this is gathering facts, gathering knowledge. So, you're going around picking up bits of knowledge, but you don't have any way, any context, and that's where the next step comes in, understanding. In understanding, you're taking those bits of knowledge that you just accumulated and try to relate one to another or put it in the right context, so this way it has meaning. The next step, applying, means that now you're trying to use this information and recall this when you need it. And at this point, uh, this is where uh, this is where education pretty much goes. Like if you're in college, um, they teach you the facts for remembering. Then you're supposed to learn. So they test you on it to see if you have understanding. And then for the final project, you have to do something, which is applying. And it pretty much seems to stay there. But there's three more. There's analyzing and evaluating. So analyzing and evaluating seems like it's the same thing, except that analyzing means that you're looking at the what you've learned and tearing it apart and seeing how it works. Why would you need it? And so you're looking more about your tools. Evaluating means that you wonder, is this the right function to use at all? Maybe there's a different algorithm, or so you're thinking more about whether or not it's appropriate. Then the next level at the top is creating. Then this is where you're actually producing something and you've pretty much mastered it, so you can do stuff on your own. Okay, so to recap, that kata is a performance, and one way to one easy way to learn is to learn one language and learn it well. Because if you know one language, then learning another language can be a lot easier, because languages tend to steal from other languages. If there's a really good concept, then they'll try to take it. For example, the Ruby has the enumerable class, and which deals with lists and sequences. And I was working on JavaScript, and I saw that there was a package called underscore. And underscore, I thought, since it's a library, it's going to take me a while to get used to. So I thought it would take me a day or two to really get a feel for it. But when I took a look, basically they implemented enumerables from Ruby. Like some of them had the same names. So instantly I knew exactly how to use this, because I've used Ruby's enumerables, and so you have this big boost of knowledge just from knowing a previous language. Okay, so I want to finish this talk by mentioning that when you first approach a language, you have to figure out what is the programming paradigm that this language falls into, and it could fall into multiple ones. So imperative language is probably the most common, because the most common type that you would experience, which is do this, here's a variable, store this value into this variable, here's a while loop that, I want you to do it while this is true. So that's an imperative language. A declarative language is something like SQL or regular expressions, where you state, this is what I want, and it'll go ahead and execute it for you. So in SQL, what you would do is you would have a select statement, and you would say select, and you give it some attributes or fields that you want to show in your report. Then you say from this table and another table, and where, and then you give it some logic. So select something from these tables where something is true, right? So that's a declarative language, and the implementation is just taken care of in the back end. All right, functional language. The functional language is a bit of a misnomer, because functional language kind of indicates that it deals with functions, but all languages have functions. So what makes it different? The difference is immutability. That means that you're not allowed to change the data. And a lot of languages, even though they're functional, they still have the ability to change the data, even though it's discouraged. But they do it for practical reasons. But in general, if you have a data structure that is immutable, that means that you're guaranteed that data is not going to change underneath you while you're using it, and so your code tends to be more correct. Object-oriented programming means that you have variables which they call objects, which have certain properties, which is attributes and behavior. So attributes are how many wheels does this have, and a behavior would be something like fetch this data. So it's able to fetch that data. And once you have a set of objects, then you want to be able to relate these objects to each other. So for example, one object, one class can be a derived class of another. So you can have inheritance. Logic programming is where you have an inference engine using logical inferences. So for example, if you had a statement that says all men are mortal, and another statement that says Socrates is a man, then if you say X is mortal, then the inference engine would go take a look and try to match something that would make this true. And it sees, oh, I know that Socrates is a man, so therefore Socrates is mortal. And the answer would come back with Socrates. Symbolic means that you have this, so the data and the code is the same. Well, it shares the same structure, so you can modify the program just like as if it was data. So Lisp is an example. So in Lisp, you have a set of parentheses. You can say parentheses A, B, C, and close parentheses, and that could be data, a list with A, B, and C. Or it could be a function, because the way that you would write functions is with a parentheses, the function name, and your list of arguments. So having parentheses A would be the function, B, C, those would be the arguments, and then you close it with the parentheses. So they look the same. It's just that the function gets evaluated. So you can generate these functions at runtime and then execute them. So that's the idea behind symbolic programming, symbolic programming languages. So once you have these paradigms in your head, you have, and you approach the language, you have to be able to make sure that you understand, you have the right framework of mind to understand what it is. Because if you don't, then you're never going to really understand the language. So this is the last slide. So I hope you find this useful and try out some of these techniques. Well, thanks for listening.